Hi, in this video we'll be talking about the basics of the iteration protocol and, to be more specific, about the concepts of iterables and iterators, which often get confused. First of all, what is iteration? Simply put, iteration is scanning objects from left to right. So if we iterate over a list, we scan all the elements of the list from left to right. A list is an example of an iterable. But we also know other iterables like strings or tuples, and not only sequences. A dictionary, for example, is an iterable as well. And here we're getting at the concept of iterables and iterators. These two notions are often used interchangeably, even in literature, but although related to each other, they do not mean the same thing. Before we try to define the two terms, let's have a look at the following example. Here we have a list of colors. This is a list, which is an iterable. We can use the for loop to iterate over the elements of the list. For color in colors, print color. Is the result. But we can also iterate over the elements of the list manually and retrieve one element at a time. The two elements we need are an iterator and an iterable. We already have an iterable, which is the list, so we need an iterator. So our first step to take is to make the iterable return an iterator. Each iterable either is an iterator at the same time as being an iterable, or has an iterator, which we'll discuss in a moment. For the time being, all we have to know is that a list is not an iterator, so it has an iterator. In order to get the iterator from an iterable, we use the iter method or the built-in iter function on the iterable, like so. C equals colors dot iter. Now what is C? C is a list iterator object. So we can use this method, iter, but we usually use the built-in iter function like so. C equals iter colors. And now C is a list iterator as well. As we can see, C is an iterator. So we can define an iterable as an object that supports the iter call. And this will do for now. So now that we have the iterator, we can use it to manually iterate over the elements of the iterable. To do so, we use either the next method or the built-in next function. So let's use both to demonstrate how they work. So here we have our list, colors. Here we have our iterator. Now we can use the iterator to iterate and to return one element at a time. So C dot next and it returns blue, which is the first element in our list. We can run it again and we get the second element in the list. Or we can use the built-in next function. Red, the next element in the list. Next, say yellow. Next, say pink. Next, say brown. Well, brown is the last element in the list. And if there are no more elements left, the stop iteration error is raised. So if we try to call this function one more time, next C, what we get is a stop iteration error. List iterators are exhaustive. It means the elements get used up as they are returned. We can use the list function to collect all the elements remaining in the iterator at any given time. So here's our list again, colors. Now C equals iter colors. So now we have our iterator, and let's use the next function to return the first element from the list, blue. Let's run it one more time, green. Now these two elements, blue and green, which have been returned, they are now used up. They are no longer in the iterator. They are still in the list, but not in the iterator. So let's now use the list function to return all the elements remaining in the C iterator. Red, yellow, pink, and brown. So as you can see, these two elements have been used up. After all the elements are used up, we get an empty list. Have a look at this. Here's our list again. C equals iter colors. And now next C, blue. Next C, green, red, yellow, pink, brown. And now as we can see, all the elements have been returned. They are now all used up. So let's use the list function to print what is remaining in the iterator. And what we get is an empty list. At this moment, we're ready to define an iterator. An iterator is an object returned by an iterable that supports the next call to return the elements one by one and raises the stop iteration error when it runs out of elements. I mentioned before that there are two kinds of iterables, ones which are iterators and ones which have an iterator. As we know, a list is an example of the latter. We can easily test whether an iterable is an iterator by trying to call the next function on it. So let's try to call the next function on our list. Colors, next colors. It doesn't work. We get a type error. List object is not an iterator. Let's have a look at some other iterables then. Iterables that are not iterators themselves include lists, which we just examined, then tuples. For example, here we have a numbers tuple. And let's try to use the next function with a tuple. Well, it doesn't work either. Tuple is not an iterator, which means if we want to manually iterate over the elements of the tuple, we have to obtain the iterator first. Let's do it now. N equals iter numbers. And now we can call the function next on the iterator. Next n 1. Next n 4. Next n 6. Next n 8. Next n 9, which is the last element, and next n we get the stop iteration error. How about strings? Here we have a string, text equals hello. And now let's try to use the next function with a string. Again, we get the type error. String is not an iterator. So if we want to iterate over the elements of this string, we first need to obtain the iterator. This time, let's use the dunder-iter method. So t equals text dot dunder-iter. Now t is our iterator, and we can use the next function to return the elements one by one. Next t h, next t e, next t l, l o, which is the last element, and then if we call next t one more time, we'll get the stop iteration error. How about a dictionary? Dictionaries are iterables too. You iterate over the keys. Here's an example. Students. A dictionary with 3 key value pairs. And now let's find out whether dictionaries are iterators or have an iterator. Let's use the next function. Type error. Dictionary is not an iterator. So we know that we need an iterator. So let's use the iter function to get the iterator. And now with the iterator, we can iterate over the elements using the next function. Next as Sarah. What we are now getting are the keys, Sarah, Ben, and Dorothy. So next as Ben, next as Dorothy, next as stop iteration error. How about ranges? Here we have a range, nums. It generates numbers from 0 to 4. Let's find out whether ranges are iterators or have an iterator. Let's use the next function with our range. Type error. Range is not an iterator. So we need an iterator. N equals iter nums. Now that we have an iterator, we can iterate using the next function. 0, 1, 2, 3, 4, and the stop iteration error. So the types we just discussed, like lists, tuples, strings, dictionaries, and ranges, they are not iterators. They have an iterator, but they are not iterators. But then we have types which are iterables and iterators at the same time. And here belong, for example, files. So let's create a file in our current directory. New text document. Let's call it workers.txt. Let's open it for edition. And let's type the following text. John Smith, 36, programmer. So we have the name, the age, and the job. And we have 4 lines altogether. So when we iterate over files, we iterate over the lines. So 1, 2, 3, 4 lines. Let's save the file. And let's go back to our IDE. And now we can use the iterator to iterate over the lines in the file. And the iterator is the file itself. So now let's open our workers.txt file for reading. F equals open workers.txt. And we don't have to pass the second argument r because it's default value. And now this file is an iterator. As the file is an iterator, we don't have to use the iter function, although we could, but it's not necessary. We can now use directly the next function to iterate over the lines in the file. So let's do it. Next f John Smith, 36, programmer. Now this is the first line in our file, and the new lines are added automatically at the end. Now next f Emma Jenkins, 38, tester. Next f William Harper, 32, designer. Next f Tom Parker, 44, programmer. As we remember, this was the last line, so let's call the next function one more time, and we get the stop iteration error. Well, we usually use a for loop to iterate over the lines in a file. The for loop uses the iterator automatically. So let's open our file one more time. And now we can use a for loop. For line in f, print line, and we can use the rstrip method to get rid of the new line characters at the end. And here we have the output, the 4 lines which are in our file. So, as you can see, we don't have to call the iter function because the file is an iterator already. Now we can close the file. Fine. So a file is an example of a type which is an iterable and an iterator at the same time. But file is not the only one. The next type, which is also an iterable and an iterator at the same time, is the enumerate. Let's have a look. P equals enumerate help. Well, an enumerate returns the elements in a sequence along with their indices. So now we don't have to use the iter function because this enumerate is also an iterator. So we can use the next function right away. Next p 0 age. So index 0 element age. Next p index 1 element e. Next p 2l. Next 3p, which is the last element, and then we get the stop iteration error. Another example are zips. Zips are iterables and iterators at the same time. Well, here's an example. Countries equals zip. And here we have 2 lists. A list of countries and a list of capitals. Now, the zip function zips these 2 lists together. As this is an iterator, we don't have to use the iter function either. And we can use the next function right away. Next countries. Germany, Berlin. So Germany is zipped with Berlin. Next countries, USA, Washington. Next, Poland, Warsaw. Next, stop iteration because this was the last element. Then we have maps. So for example, here's a list. Nums equals 1, 2, 3, 4, 5. And now we have squares equals map. Here we have a function and our list. So this means this function should be applied to each element in this list. Well, map is an iterator, so we don't need the iter function either. Let's use the next function right away. Next squares 1, because this is 1 to the power of 2, which is 1. Next squares 4, because 2 to the power of 2 is 4. Next 9. Next 16. Next 25. Next stop iteration error. Then we have filters. Here we have a list of words and a filter. Short words equals filter. Here we have a function and here is our words list. So what a filter does is it filters out the elements from the list for which this function returns false. So only those elements are left for which this function returns true. In this case, only the words with a length of less than 4 characters will be left. Okay? Now a filter is an iterator, so we can use the next function right away. Next, short words, bad. Yeah, good was filtered out because it's too long, but bad is less than 4 characters. Next, old. Next, new. Next, stop iteration error. Each of the iterators can be used manually, like before, or automatically in a for loop. Here's an example with a map. Symbols equals map, here we have the function, and here we have a list. And now we can use a for loop. For symbol in symbols, print symbol. And this is what we get. The slices consisting of the first 3 characters in each of these elements. Here, 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 and here. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.